Lesson 8 is about exponential growth and decay, and we've talked about exponential functions in the past. Exponential growth functions are just ones that are increasing over time, and exponential decay functions are ones that are decreasing over time. So starting in the upper left in that blue box, this is a baseball card bought for $50, increases 3% in value each year. So because it's increasing in value, this situation is an example of exponential growth and can be represented using the formula f of x equals a times 1 plus r to the x power, where a is going to be our starting amount, r is going to be our rate, and it'll need to be in decimal form before it goes into the formula. And then x is going to be our time, and that can vary. It can be like days, weeks, years, anything that's given to us in the problem. And then the red box, a car valued at $15,000 depreciates. That means it goes down in value. It depreciates at a rate of 14.3% each year. This situation is an example of exponential decay because it's losing value. It's decreasing in value. And it can be represented by the formula f of x equals a times 1 minus r to the x power. And then you can see there's a lot of similarities between the two formulas. A is the same thing. It's there. That's going to be the starting amount. R is the rate. It needs to be in decimal form here as well. And then X is the time. And again, that can vary. It could be days, weeks, years, whatever is given in the problem. So notice that between the exponential growth formula and the exponential decay formula, they are almost identical. The only difference is that exponential growth has a 1 plus R, making the growth factor greater than 1. And then exponential decay has a 1 minus r that makes the growth factor less than 1. So between 0 and 1. Okay, so definitely save these two formulas and kind of keep a note of which one is used when. So if we're increasing in value, we would be using the 1 plus r. If we're decreasing in value, we'd be using the 1 minus r. And then before we get into the examples, I just jotted down some like common growth words as well. So for growth words, this is like when you're reading a word problem. These words would help you decide that you want to use the exponential growth formula. So increases, this is appreciates, that means it like goes up in value. Gains, grows, rises, expands, doubles, triples, all those are examples of growth words. They're not all of the growth words, but some pretty common ones. And then for decay words over here, could be decreases, depreciates, loses, reduces, shrinks, falls, halves, thirds. Again, not all of them, but some common ones. Anytime you see a word like that in your word problem, it would be an indicator that you would want to choose the exponential decay formula because your value would be decreasing over time. Okay, so example 1, the inaugural attendance at an annual music festival is 150,000. The attendance increases by 8% each year. Write a function that models the festival attendance, So we have to decide which formula we want to use first. It says that the attendance increases by 8% each year, so that means it's growing. So we'd want to use the exponential growth formula. So I'm going to take this formula right here, and I'm just going to copy it down. So it'll be f of x equals a times 1 plus r to the x. And then when we're writing our actual function, we need to find something to put in for a, that's going to be our starting amount, and then we need to find something to put in for r, that's going to be the rate that it's increasing by. When we're just writing our function, we don't need to put anything in for the time yet because it's supposed to be for like any amount of time when we write the original one. So it says that the inaugural attendance at an annual music festival is 150,000. Inaugural means like the first year that they have it, so that 150,000 is going to be our starting amount. So the first year they hold the music festival, the attendance is 150,000. So that's going to be our A. And then for our rate is how much it's going to be increasing by, and it says the attendance increases by 8% each year. So that 8% is going to be R. However, we have to convert this to decimal form. Right now it's in percent form because you have the percent symbol there. So there's two ways to convert between percent and decimal form. One is by taking your percent, 8, and dividing it by 100. So that would be the same thing as 0.08 if we did 8 divided by 100. The other way of converting it is if we take wherever there's a decimal place, and if it's a whole number, the decimal would be after. And if we move it twice to the left, that would give us our like decimal version of that percent. So if we move like from like to the right of the 8, if we move the decimal place twice to the left and put it there, we'd have to add in a 0 as a placeholder, and that would give us the same 0.08. So whatever you're more comfortable with, but you could always just take the percent and divide by 100. So like here, and then divided by 100 to get our decimal 0.08. So that's what's actually going to go in the formula itself. Okay, so we'll do f of x equals, instead of a, I'm going to put in the 150,000. And then times 1 plus r, but r is going to be 0.08, so 1 plus 0.08 to the x. And then we always just want to kind of leave our formulas like in their most simplified form, or as simplified as we can get them. So that means that we would just want to go ahead and add these two together inside the parentheses because we can, so why not? So our like final simplified version of this would be f of x equals 150,000 times 1 plus 0.08 would be 1.08, and then to the x. And then this is going to give us our like final rule that represents the population after really any amount of time, because we have just a variable in there for x. Oh, it's not turning into a rectangle. Bugs me when it doesn't. Okay, anyway, so f of x equals 150,000 times 1.08 to the x. If you're wondering why we don't multiply these two together to get them more simplified, is because we can't right now, because order of operations would tell me that I need to simplify exponents first before multiplication, and since the exponent is an x, I can't simplify because I don't know what that number is. Okay, so I'm just going to shrink this down because I wrote a little bit big for this section. And then for the next part of this problem, it says how many people will attend the festival in year 5. So we talked about how x is the time, and this is asking how many people will attend the festival in year 5. So that means that we have to put 5 in for x into the rule that we just created and then evaluate it. So instead of f of x, we're going to find f of 5. And that means the function evaluated at 5. So it'd be equals 150,000 and then times 1.08. And then instead of to the x power, it'll be to the 5th power. So 150,000 times 1.08 to the 5th power. And then the rest of this problem we have to do on a calculator. Okay, so I'm just going to use the Google calculator. If you go to Google, type in the calculator, it pops up at the top. So we have f of 5 equals 150,000 times 1.08 to the 5th power. We have to follow order of operations first, which is PEMDAS or GEMS. Let's see if I could squeeze it in here. So PEMDAS. Okay, so parentheses, the P is referring to if there's anything we can simplify inside the parentheses, we would do that, but there's nothing there because it's just the one number. So next would be exponents. So we have to take 1.08 and raise it to the 5th power. So to do that on this calculator, we would type in 1.08. And then if you have the full screen on, you probably don't have to do this next step, but I have just the half screen, so I have to click over to f of x. And then I need the button that has x with a little y exponent. So on mine, it's the bottom row and it's the 3rd button over. And then that pops up the little button for the exponent, that little blank. And then I'll go back to my numbers and type in a 5. So you see 1.08 to the 5th power. And it's about 1.47, because if we wanted to round to 2 decimal places, we would look at the 3rd number, which is 9, and that would round the 6 up to a 7. So this would be 150,000 times about 1.47. So for this next part, I can just leave this number in my calculator as is. I don't have to change it into, let's see if I can get this over here. I don't have to change it into 1.47. In fact, it's more accurate if I just leave the entire decimal in my calculator. You should get a close enough answer though if you do happen to change it to 1.47. So now I have to take that like number 1.47-ish, that long decimal, and I have to multiply it by 150,000. So I'll just keep it in my calculator, hit the multiplication button, and then times 150,000. And then hit equals, and it's 220,399. And in this case, we don't want to round to 2 decimal places because it's asking about the attendance at a music festival. So I don't want to say that there's like 0.2 people in attendance because that would be just a part of a person. So whenever you're dealing with problems that involve people, you want to round to a whole number. So we would say f of 5 equals 220,399, and I'm just going to stop there. And that means that in year 5, that's f of 5, the attendance will be 220,399, about that. Okay, so moving on to example 2, it says an endangered bird population decreases at a rate of 1.4% per year. There are currently 80,000 of these birds. Write a function that models the bird population. So we have to look for one of those keywords that tells us, okay, is this growth or is this decay? And it says that an endangered bird population decreases at a rate of 1.4% per year. So that means that it's going down, and we're going to use the decay formula. So I'm going to copy this one down. So it'll be f of x equals a times 1 minus r to the x. It's decreasing, so we have to use the 1 minus r. And then now we have to figure out what, I don't know what happened to the other side of the screen, but now we have to figure out what value goes where. So actually I want to see these ones on the screen. So remember that a is going to be our starting amount, and it says in the problem in the second sentence that there are currently 80,000 of these birds. So we have to put 80,000 in for a. And then it says that the bird population decreases at a rate of 1.4% each year. So 1.4 is going to be our rate. So that 80,000, that's our A, and then 1.4 is going to be our rate. I'm going to write that up here though. So we say rate R equals 1.4%. But remember, we have to convert that to a decimal before we put it into the formula. And I know that like there is a decimal in 1.4, but if it ends in a percent symbol, it's in percent form, so we still have to convert it. So we would take 1.4 and we would either like divide by 100, so that would become 0.014, or you could just take the decimal place and move it twice to the left, and we'd put a 0 here as a placeholder, so 0.014. So you end up with the same thing, whatever is most comfortable for you. And then for this one, I'm not going to rewrite the formula. I'm just going to take out A and like replace it with 80,000, because we know 80,000 is the starting amount. So 80,000. And then I'm going to take out R and go ahead and put our rate in. So we'll take out R, put in our rate of 0.014. So 0.014, sorry, my like kind of little decimal got stuck in the middle there. So 0.014 is our rate. So altogether we have f of x equals 80,000 times 1 minus 0.014 to the x. And then same thing as the last problem, where if we can simplify it, we want to. So that means that we can subtract inside the parentheses. So it'd be f of x equals 80,000 times 1 minus 0.014. I don't want to mess it up in my head. So 1 minus 0.014 is 0.986. So 0.986 once we subtract those, and then to the x power. So this is our function that represents the bird population for like any amount of time, because we just left x in there. Again, just having bad luck with the rectangle today. Okay, sorry. Okay, so f of x equals 80,000 times 0.986 to the x power, and again, this represents like any year because we're leaving x there. And then for the second part, it says how many birds will there be in the 10th year? So remember that like x represents the year. So if it's asking like how many birds will there be in the 10th year, we have to put 10 in for x and then evaluate it just like we did in the first problem. So instead of f of x, it'll be f of 10. Putting 10 in for x, and then we'll take our function from up here, 80,000 times 0.986, and then to the 10th power, because we're putting 10 in where that x was. And then so we have f of 10 equals 80,000 times 0.986 to the 10th, and the rest of it is the calculator. So pull up the calculator. Okay, so same thing here, we have to follow order of operations and we simplify exponents before multiplication. So I would have to simplify the 0.986 to the 10th power first. I can't stress it enough, if you multiply by 80,000 first, you're going to get a different answer. So we'll do 0.986. And then on mine, since I have it in the split screen, I have to click f of x. If yours is like that too, you may see all these buttons on one screen though. So now the button I need is the x to the y power. On mine, it's the bottom row and it's the third one over. And you can see it pops up a little box for an exponent, and then I go back here and I do the 10th power. So it equals about 0.86849 and so on. I'm just going to leave that in the calculator though, because it's going to end up giving me a more accurate answer, but I'm going to write the next step down here just so it's a little easier to follow. So it'd be 80,000 and then 0.986 to the 10th. If I rounded this to 2 decimal places, I would have to look at the third number, so it'd be 0.8, and then the third number is a 5 or more, it's an 8, so it would round the 6 up to a 7. So 0.87, but again, I'm just going to leave this long decimal in the calculator. It'll end up giving me a more accurate answer. So it'd be 80,000 times 0.87, or the entire decimal, so times 80,000 equals 69,479.89. But again, here we're talking about like a bird population, so I don't really want to say that there is 0.89 or 0.89 or 89 hundredths of a bird, because it's not a complete bird. So we want to round to the nearest whole number, so I'm going to round it up since that's a 0.89. So we'll say f of 10. And I'm going to throw the little like approximately equal sign. I should have done that on the last problem, so I'll go back and add it. But the little squiggly equals means approximately instead of exactly. 69,000. And then instead of 479, it's going to round up to 480. So f of 10 equals 69,480. That means after 10 years, f of 10, the bird population is approximately 69,480. Okay, so I'm going to go back and change example 1 to an approximately, just because it's not exactly that number. We had to round it a little bit. So we'll say f of 5 is approximately 22,399. And then for example 2 is f of 10 is approximately 69,480. So we have one example of growth, we have one example of decay. It's good to get comfortable with both, but the biggest thing for this section is making sure that you are able to recognize the growth and decay words, so that when you read the word problem, you know which formula you need to use, because we got to get the right formula to get the problem correct. Okay, so example 3, this is the last example. It says volunteers recently planted a new tree in the town square. The tree began with 124 leaves and its leaves are doubling in number each month. Write a function that models the amount of leaves on the tree. So we have to decide whether it's going to be growth or decay. It says that the leaves are doubling in number each month. So it's growing, it's increasing in its amount of leaves. So we'd use the exponential growth formula. So it'd be f of x equals a times 1 plus r to the x, because it was doubling. Okay, so now we got to figure out, okay, what is a and what is r? So we know a is our starting amount. It says the tree began with 124 leaves, so that's going to be our starting amount. So we'll put 124 in for a. And then if we look through this problem, we read through it again, there's no percent in there. There's no like increasing by 4% of their leaves or like 50% of their leaves or something. But it does tell us that the leaves are doubling. So if you see a word like doubling or tripling or anything like that, that's not only like our indicator word for increasing, it also tells us our rate. So this is something that's probably pretty new. But if you see that like something is doubling, that means that it's increasing by 100%. So if you're doubling a number, you're increasing by like the full amount. Like if I had 2 cookies and then I doubled them, I would have 2 more cookies. So I'd be like adding 100% of what I originally had. So that's pretty important. I don't think that's super like common sensey sometimes. So that's not a word, but I'm sorry. But doubling would mean that you're increasing by 100%. So R would be 100%. And if we wanted to convert that to a decimal, we would have to do 100% divided by 100, which 100 divided by 100 would be 1. So R would be 1 is what we would put in here. And then just in the future, if it ever comes up, if you're tripling, you would be increasing by 200%. And I'll show you a little bit easier way to do it after we finish setting up this problem. Okay, so we'll go ahead and put everything in. So it'd be f of x equals, A would go right here. It starts with 124 leaves. And then times 1 plus r would go right here, which is r was 1, so and then to the x power. And then if we can simplify it, we should. So we can simplify by adding the numbers inside the parentheses. So it'd be f of x equals 124, and then 1 plus 1 is 2 to the x. So f of x equals 124 times 2 to the x. We talked about in a previous section how this number that's being raised to the x is the growth factor. So sometimes when you have a word like doubling or tripling, it's almost easier to kind of skip the like 1 plus r aspect of it, and just if you're doubling, your final growth factor would be 2. If you're tripling, your final growth factor would be 3, and so on. So if you feel comfortable, you can use that if you ever have a problem that says like doubling, tripling, words like that, rather than like increasing by 4% and giving you a kind of percentage. Okay, so f of x equals 124 times 2 to the x power. Again, over 3. Okay, I'm sorry. My rectangles are too bad for them to recognize them. Okay, so last little part. This growth will only last for 3 more months until the end of the summer. How many leaves will it have before autumn? So they plant the tree, and then the leaves are growing, but at a certain point it's going to be autumn and the leaves are going to fall out. So they're saying that time frame that it has before the leaves start falling out is 3 months. So we just need to figure out how many leaves it has in 3 months. So we know that like x is time. And in this case, it's saying this growth will only last for 3 more months. So we need to put 3 in for x. So we'll find f of 3 instead of f of x. And then equals 124 times 2. And then instead of to the x power, we would do to the 3rd power. Okay, so if you want to kind of do this first part on a calculator, you can, but I would like to encourage you to try not to if you feel comfortable. So 2 to the 3rd power, we know we're going to simplify the exponents first. 2 to the 3rd power means 3 2's being multiplied, so it means 2 times 2 times 2. So 2 times 2 times 2 is 8, because like 2 times 2 is 4, and then times the 3rd 2 would get you to 8. So this would be 124 times 8. And then now we can just multiply those 2 together. So again, you can use like the calculator the same way we did the previous problems. But I mean, 2 times 2 times 2 is a little bit easier to figure out than like 0.986 to the 10th power like we did over here. So we'll do 124 times 8, and that is 992. So f of 3 is 992. That means that the tree is going to end up with 992 leaves before they fall out.